Welcome to the Supercharged Batteries module on Battery Basics. Here we'll describe some key information about battery technology and give you that confidence to deliver an excellent customer experience every time. Before we can understand why supercharged batteries are superior to other brands, we should take a quick look at what a battery is, what they do, how they do it, and how we measure what they do. A battery is a device that stores electrical energy in chemical form. The stored chemical energy is converted directly into electrical energy when the battery is connected to an electrical load or upon demand. Lead-acid batteries are the most common type of batteries and are used in a wide range of energy storage needs. Applications include starting, lighting and ignition, or SLI, used in applications such as automotive, motorcycles, truck and marine. Lead-acid batteries can be flooded as either low maintenance or maintenance free. And batteries with absorbed electrolyte, which are valve-regulated lead-acid batteries or VRLA. Low maintenance batteries have a low antimony content on both plate grids, a high gassing and corrosion rate, and may require topping up. Maintenance-free batteries, on the other hand, have lead calcium on both plate grids, are usually fully sealed units with no topping up of water required, and have a very low gas evolution and corrosion rate. Absorbed electrolyte or VRLA absorbent glass mat, AGM batteries, are specialty batteries that have high gas recombination efficiency. They are sealed lead-acid batteries, where the electrolyte is absorbed in a fiberglass mat separator. These are leak and spill-proof and usually designed for sophisticated equipment. A battery has three major functions. Firstly, it supplies power to the starter and ignition system to start the engine. The battery cranks or rotates the crankshaft, while at the same time it maintains sufficient voltage to activate the ignition system until the engine fires and maintains rotation. Secondly, it supplies the extra power necessary when the vehicle's electrical load exceeds supply from the charging system. And thirdly, it acts as a voltage stabiliser in the electrical system. So, how do lead-acid batteries work? Let's take a look at the charging and the discharging process. The process of generating power by the travelling of the electron from the positive to negative plate is the same with AGM batteries. However, the medium is different, as absorbed types use an absorbed glass mat separator, which is compressed in between plates. This results in a spill-proof design and an impact-resistant battery. Now let's talk performance. In particular, what we can achieve from our battery in terms of its capacity and how we measure it. When talking about capacity, we are referring to the electrical charge stored in the battery and available for transfer during discharge. We express this in terms of ampere hours, AH, known as the 20-hour rate. A battery having 100 amp hour rating must be able to carry a 5 amp load for 20 hours and still maintain a terminal voltage of 10.5 volts at 27 degrees Celsius. Amp hours can also be expressed as 10-hour, 5-hour or 1-hour rates. Motorcycle batteries are generally expressed as 10-hour capacity rate, while other international standards would express capacity of automotive as 5-hour rate. What about the term reserve capacity, or RC? The RC rating measures the battery's ability to carry a 25 amp load at room temperature. The reserve capacity can be determined by how many minutes it takes the battery's terminal voltage to reach 10.5 volts. This gives the consumer an idea of how long a fully charged battery can support a vehicle when the battery experiences parasitic drain while the key is off, and when the vehicle's charging system fails. Another measure of capacity relates to cranking ability. The starting or cranking battery type is designed to deliver large bursts of power for a short period of time, as needed to start an engine. The measure of the battery's ability to provide this current is through cranking amperes. This can be expressed as marine cranking amps, measured at 0 degrees Celsius, hot cranking amps at 27 degrees Celsius for hot or tropical climates, or cold cranking amps, measured at -18 degrees Celsius, which is applicable for cooler climates. Here we measure the ability of a fully charged battery to continuously deliver the rated amps for 30 seconds and still maintain a minimum voltage of 7.2 volts for a 12-volt battery. When measuring how much energy the battery is delivered, we look for its depth of discharge, or DOD. Determining DOD is another way to arrive at the battery's SOC, or state of charge, expressed as a percentage. As one increases, the other decreases. Related to depth of discharge is cycling, of which there are three types. Shallow cycling, repeatedly discharging only a small proportion of the battery's capacity and then recharging again, typically used for starting applications. Semi-deep cycling involves repeatedly discharging a moderately high proportion of its capacity and recharging again. Deep cycle batteries are used for providing low but steady level of power for a longer period of time than a starting battery. Now that we have covered the battery basics, let's have a look at the components of a battery. The casing safely holds the active materials and electrolyte within the battery. It must be sturdy and it cannot degrade under the typical conditions experienced. The grids are the skeleton of the active material and serve as an electrical conductor which bonds to the active material. They must have the ability to withstand normal handling and processing, must have low corrosion and low electrical current. Lead-based paste serves as active material that generates electrical energy through a chemical reaction with the electrolyte. Plate separators serve as an electronic insulator that insulates the positive active material from the negative active material, preventing a short circuit in the cell. At the same time, it serves as an ionic conductor, which allows the exchange of ions between the battery plates, allowing the current-generating chemical reaction to proceed. Lead connectors include straps that connect the plates of the same polarity, have low electrical resistance and add mechanical strength. While intercell connectors, quite literally, interconnect the cells in the battery and reduces resistance by connecting through the partition wall. The electrolyte is a diluted sulfuric acid, which directly participates in the chemical reaction that generates electricity. So, it too is an active material. The cover, like the casing, should not degrade under service conditions. Covers must have a gas venting system, either from the plugs installed in the cover or incorporated into the cover construction itself. Lead terminal posts provide a means for connecting the battery to an electrical load outside of the battery. They require mechanical strength as well as low electrical and corrosion resistance. Lead-acid batteries need not be overly complicated to understand or explain to your customers. You should now have the confidence to advise your customer on battery basics and provide an excellent customer service experience every time.